we have already seen the chromatic number, right? Chromatic number means vertex coloring. Chromatic number, what is chromatic number? This is the minimum number of colors needed to vertex color a graph. Okay, so this is called chromatic number. Now, in this chromatic number, one statement we have seen that for any graph, okay, any graph G you take, for any graph G, what we know? We know that this chromatic number is less than equal to the maximum degree plus 1. This statement we have seen for any graph, this will happen. Okay, for every graph, this will happen that the chromatic number is less than equal to maximum degree plus 1. This is the maximum degree of the graph. This is the maximum degree of graph. Okay, so this is the maximum degree of graph. Now tell me, so this statement we know, we have already seen this statement. Can anyone give me one example where this will become exactly equal? Where this will become exactly equal? Can anyone tell me? Okay, can anyone give me a graph for which this will become exactly equal? We know that for every graph, you know that for every graph, whatever graph you take, for every graph, what will happen? For every graph, this will happen, that the chromatic number is less than equal to delta plus 1, where delta is the maximum degree of the graph. So tell me, anyone want to give me a graph? Okay, so give graph. This is the question basically. Give graph for which, okay, for which delta or this chromatic number is exactly equal to delta plus 1. This is exactly equal to delta plus 1. So which graph you will give me? Okay, so yes, the first graph that you can give me is odd cycle. Odd cycle you can give me, right? Yes or no? The first graph you can give me is odd cycle. Odd cycle. This odd cycle you can give me. In this odd cycle, what will happen? Like this is an odd cycle. This is an odd cycle. This is an odd cycle. Like C3, C5. So tell me, what is the maximum degree in this odd cycle? What is the maximum degree in odd cycle? What is the maximum degree? Maximum degree is 2. Correct? Maximum degree is 2. But what is the chromatic number of the odd cycle? What is the chromatic number of the odd cycle? That is 3. Okay. So you can clearly see that chromatic number is equal to 2 plus 1. Okay. Chromatic number. So this is the idea. Chromatic number of odd cycle. Chromatic number of odd cycle, that is maximum degree plus 1. Okay. And maximum degree is 2. This maximum degree, this is your 2. Okay. So this one graph you can give me. Another graph, what you can give? Another graph you can give is complete graph. Kn you can give. In this Kn, first of all, tell me what is the chromatic number for this Kn. What is the chromatic number of Kn? The chromatic number, every vertex should get different color. Every vertex should get different color. And what is the maximum degree in this Kn? What is the maximum degree? Every vertex has degree n minus 1, because every vertex has n minus 1 adjacent vertices. Okay, so every vertex has n minus 1 edges. So very simple. So every vertex has degree n minus 1. Again, you can notice that this will happen. Now, let me tell you one very interesting thing. One very interesting thing. Is there any other graph? Is there any other graph for which this will happen? Is there any other graph for which this will happen? Is there any other graph? Let me tell you, there is no other graph. Okay. So there is no other graph. There is no other graph. There is no other graph for which chromatic number will be equal to delta plus 1. Okay, there is no other graph. Only these graphs are there. There is no other graph where chromatic number is. What is the chromatic number of Qn? Like someone is saying, Saurabh is saying Qn. What is the chromatic number of Qn? Tell me, what is the chromatic number of Qn? Chromatic number, Qn is a bipartite graph. Qn is a bipartite graph. In the last class, we have already seen the chromatic number of Qn, that is 2 for n greater than equal to 1. That is 2 for n greater than equal to 1, and that is 1 for n equal to 0. Okay, so that we have already seen. So you can notice this is interesting, right? This is interesting that these are the only graphs. These are the only graph, this odd cycle and this complete graph. These are the only graphs where delta is equal to the chromatic number is equal to maximum degree plus 1. No other graph for which, okay, this is known as Brooks theorem. This is actually this is proven by Brooke. Okay, so this is known as Brooks theorem. What he says that all connected graphs have this chromatic number is less than equal to maximum degree. Okay, this chromatic number is less than equal to maximum degree except Kn and odd cycle. So basically this is the idea. Only these are there, only these graphs which Kn comma odd cycle, only these graphs are there for which chromatic number is equal to maximum degree plus 1. And for all other graphs, for all remaining graphs, for all other graphs, remember, for all other graphs, what will be the chromatic number? The chromatic number is less than equal to delta. The chromatic number is less than equal to delta. Okay, only these graphs we have where chromatic number is delta plus 1. Only these two graphs, complete graph and odd cycle, only these two graphs we have. So Brooks theorem is important because that tells you that only this complete graph and cycle graph, or sorry, odd cycle, complete graph and odd cycle, only these are the graphs where chromatic number is equal to maximum degree plus 1. For all other graph, for every other graph, the chromatic number, okay, and we are talking about connected graph, we are only talking about connected graph. For all other connected graph, the chromatic number will be less than equal to delta. Okay, this is your Brooks theorem. Okay, so we are talking about connected graphs. This is your question. Consider this graph. So this is your graph G. Let us assume this is your graph G. This is the graph G. Then what is the chromatic number of graph G? What is the chromatic number of this graph G? So for this graph G, you can notice one thing. You can notice that all the colors that you have, all the colors that you use here, those you can use again. For example, if I use, let's assume if I use red color here, okay, green color here, black color here, because this is an odd cycle. This is an odd cycle. Now this red color I can use again here, no problem, because there is no problem. I can use red color here, black color here, green color here, yellow color here. Again I can use red color here, black color here, red color here, black color here. Again I can use red color here, red color here. So ultimately the chromatic number is basically equal to, okay, the chromatic number is actually equal to 4. The chromatic number is actually equal to what? 4, yes or no? Because your graph is like this. So the chromatic number will be this. Can I say this very interesting note? Can I say that if you have, let's assume you have a graph with k components. Let's assume you have a graph with k components. There are k components. Okay, k components. If you have a graph with k components, then what can you say about the chromatic number of this graph? The chromatic number of this graph, that will be equal to the maximum among, okay, chromatic number of each component. Yes or no? Yes or no? The maximum of, you take maximum of chromatic number of each component. Like, see, this is your graph. Total how many components you have? Total 5 components you have. Total 5 components you have. Then the chromatic number of this graph, this will be the chromatic number of this graph. Very simple. Because these are the, this component is using maximum number of colors. This component, this is using maximum number of colors. Okay, this is using the maximum number of colors. All other, they are not using as much as color as this. This is using maximum number of colors. So I can say that chromatic number of this whole this graph, that is the maximum among all the chromatic number of all components. Maximum of all components. Chromatic of all components. Okay. So just take max of chromatic number of components. Very simple, isn't it? Just take maximum of chromatic number of all components. Just take the maximum. Okay, that will be your idea. So for example, here I can say, so this will be actually the maximum of, this will be the maximum of 3, 4, 2, 1, 1. Okay, and this, that will be 4. This is what you have to take.